Factoring out a greatest common factor. We discussed the distributive property and how we can use the reverse distributive property to help us factor. And factoring is so that we can write an expression as a product of some factors. And for a polynomial, the greatest common factor is the largest polynomial that will evenly divide into that polynomial. And evenly divide means that we aren't left with any fractions. Everything divides out to whole numbers. To be in factored form, we have to have a product of factors. So factoring gives you another way to write an expression equivalent to the original problem, and it allows us to simplify rationals and solve quadratic equations by factoring in the future. And it helps us to find the zeros of an equation where the x-intercepts are, and there are a lot of uses for factoring that we will need soon. So identify the greatest common factor of a polynomial will be our first step, and then we'll divide that greatest common factor out of every term in the polynomial, and then we will check our answer using the distributive property. So let's take a look at it at an example. When I look at this, I want to find the greatest common factor, so I'm looking at just the numbers first, and I have an 8 and a 4, and I know they're both divisible by 4. So my greatest common factor has a 4 on it, and maybe some variables too. So let's look at those. So we have an x squared and an x, and remember, for a greatest common factor, we're going to have to be able to divide by it and come up with no fractions at the end. So we take the smallest exponent for any of the variables, and the variable has to appear on every term. So we'll look here, we have x squared, here we have x, so we can only put x on here for our greatest common factor. Same thing with the y's, they're just in the opposite order. I have a y here and a y squared here, so I have to go with the y for my greatest common factor. So I found my greatest common factor. Now I'm either thinking about it as 4xy times what is going to give me that first term, and times what is going to give me the second term. So 4xy times what will give me 8x squared y. And I can start with the numbers. 4 times 2 will give me 8, so I know 2 goes here. And then x times what will give me x squared. Well, I need another x. And then y times what will give me this y over here. And I've just got a y, so it would be a 1, so I really don't have anything to think about there. Times 1 won't change my value at all. The second term, this one here, I'm looking for what do I multiply positive 4xy by to get this negative 4xy squared. Well, I already know I need a negative there, and 4 times 1 is going to give me that 4, so I only need a 1 here. And then this 4, then I can look at the x. X times 1 is going to give me the x here. And then the y. Y times what will give me y squared? Well, I need another y. So I kind of wrote those out, all the little pieces, but really what it should be is 4xy times 2x minus y. That would be the factored form of 8x squared y minus 4xy squared. Now the other way, divide the greatest common factor out of each term, would look like this. So I'd have 8x squared y divided by the greatest common factor of 4xy minus 4xy squared over 4xy, the greatest common factor. And then I want to reduce each one, so the 4 goes into the 8 2 times, x goes into x squared x times, and the y's reduce completely to 1. And then I have minus in between, I don't want to lose that. The 4's reduce completely to 1 over here. The x's, same thing, to 1. And the y's, I have a y left on top. And so when I rewrite that, I have 2x minus y. But that's just the part that goes inside the parentheses. The greatest common factor that I divided out has to go at the start. And you can see I ended up with the same expression, both methods. Check your answer using the distributive property. Let's try that because we want to make sure that we know how to check ourselves, so if we're stuck we can see if we're right or not. So I have 4xy times 2x minus y, and I'm going to take that whole 4xy and distribute it inside the parentheses. So it's going to be 4xy times 2x, and then minus, for that minus in between, 4xy times y. And then when I write that out, I'm going to have 4xy times 2x. So the 4 and the 2 can multiply, and I get 8. And the two x's can multiply, and that'll be x squared, and then just a y on the end. And the second term, I have 4. There's nothing to multiply the 4 with. The x, same thing, but the y's can multiply, so I'll have 4xy squared. Now this, what I come up with from multiplying, should equal what I started with, 8x squared y, 8x squared y, minus 4xy squared, 4xy squared. So those do match, and so that tells me the factored form that I came up with is equivalent to what I started with.
Number 2, we have a negative on the first term. Xy is probably not the highest degree. When I'm looking at it, I want to see if there's a greatest common factor first, and I see the 6 is divisible by 2 and 3, and the 3 is just a 3. The 33 is 3 times 11, and so I can see that all of them have a 3 in common. So my LCD, or my greatest common factor, is going to have a 3 on it, and then I need to look at the variables, and I have an xy on all 3 of them, so I know I'll have an xy on my greatest common factor, and I'll take the smallest exponent for each because that's the biggest number I can divide each one by. So x and y to the first here, so I'm not going to even need to look further. I can't go any higher than xy, or I'll be left with a fraction for my first term. So then I have 2 options. I can factor out a negative 3xy because I do have a negative sign on some of my terms, or I could just factor out a positive 3xy. And it's really your option, and it's going to depend on what you're doing with the polynomial next. So if I factor out a negative 3xy, I'll show you that first. Then I'm thinking negative 3xy times what is going to give me a negative 6xy. Well, if I just look at the number parts first, negative 3 times what will give me negative 6, and my answer is 2. And then xy times what will give me the xy part, and it's just times a 1. So I'll just leave it as a 2. And you can think of it as then negative 3xy times 2, which will give me negative 6xy. And that's my first term. The second term, negative 3 times what will give me a positive 3, and it'll have to be a negative 1. And then x times what will give me x, it'll just be an x, or just a 1, I'm sorry. And then y times what will give me y cubed. Well, I have y, and I need 2 more y's to multiply to give me y cubed. So it's just going to be y squared. And I can take off that 1 on there now. And then negative 3 times what will give me 33. And it's going to have to be a negative 11 because negative times negative will give me positive. And then x times what is x cubed? Well, I'm missing 2 x's being multiplied there, so I'll put them on. And y times 1 will give me y, so I don't need anything for the y's. So this will be my factored form if I factor out the negative with the greatest common factor. Now, if I just do it as 3xy as my greatest common factor, it's pretty similar, and I'll show this one in the other manner where I'm dividing terms. So I have negative 6xy divided by 3xy, and that's the first term, and you can see that the xy's are going to reduce. 3 goes into negative 6 negative 2 times, so I'll have a negative 2 for my first term. And then let's look at another one. So I have, let's see, 3xy cubed divided by 3xy. So that one in blue. So the 3's will reduce and I'll just have a 1. The x's will reduce and then y into y cubed, there will be y squared left over. And remember this had a plus in front of it, so it's going to be plus y squared. And then my last term was plus 33x cubed y, and I'll divide it by that greatest common factor, 3xy, and I want to simplify and see what I end up with. 3 goes into 33 11 times, x goes into x cubed, x squared times, because remember x cubed is really xxx, and I have it over a single x, so those will go, and I'm left with 2 x's multiplied in the numerator. And then finally, y over itself is just 1. So for the last term, I have plus 11x squared. So I sort of showed you a mix of two methods on this problem. One is factoring out the negative on the greatest common factor, and the second is leaving the negative in the problem. And you can see the difference here, and I'll show you and then I'll erase. But you can see this negative is not there on the greatest common factor. That was our point. And you can see basically our signs are exactly opposite from one version to the other. And you should see that every time. So I'll go ahead and erase those now. Check your answer using the distributive property. So if I have negative 3xy times the quantity 2 minus y squared minus 11x squared, and I want to check it, I'm distributing this negative 3xy inside the parentheses, so each term is going to get multiplied by that 3xy. So I have negative 3 times 2, so negative 6, and then I have xy, and then I have negative times negative for the next term, so that's going to become a positive. Negative 3 times, there's an implied 1 right here, so that'll be a positive 3. And then x, there's no x's to multiply by, so just a single x on the second term. And then y times y squared. So I have y times y squared, which is y times y. And it looks like a y cubed. So I have 3xy cubed. And then negative 3 times negative 11, that'll be positive 33. And then x times x squared, that'll be just like the y's we did, so x cubed. And then a single y being multiplied as well. So double check, negative 6xy, 3xy cubed, 33x cubed y. So that one checks out. And I want to do one more check, and that is of my second form, which didn't have the negative. So 3xy times negative 2 plus y squared plus 11x squared. And this time I'm distributing a 3xy inside, and here I end up 3xy times negative 2, so I'll have negative 6xy. Second pair multiplied 3 times an implied 1 here, so it'll be positive 3. X times no other x's, so just an x, and then y times y squared, so I'll have y cubed. 3xy times 11x squared, so it's a positive. 3 times 11 is 33. X times x squared is x cubed, and y times essentially 1 is y. And then I can double check, negative 6xy, 3xy cubed, 33x squared y. So that one checks out as well. So I have two equivalent forms that are factored. One of them had a negative pulled out on the greatest common factor and the other did not. And it is your option which way you want to go on that.